My name is Peter, and I'm here to talk to you about Android security. So, on your day planner, on your schedule, you're going to see this as Demystifying Android Security. That's a bullshit title I use to decoy all of you guys into here. The actual name of the talk is Attack Vectors. A, because it sounds cool. Number two, because attack vectors are what hackers actually use to get into your app. So what we're going to be talking about today are three major attack vectors. So the first one is going to be your network layer, or your communications layer. And that's the one that's like totally the most important one, but it's also the one that's easiest to protect, and that's great. We're also going to touch, while we're talking about that, while we're talking about the network, we're also going to talk about HTTPS, what it is. A bunch of you probably already know this, but whenever I talk about this, everyone always kind of goes vague and glassy-eyed. So we're just going to kind of demystify that, if you will. What else? Oh yeah, certificate pinning. But more on that later. After that, we're going to be talking about the storage layer, where to store your users' information. When is it safe to store your users' information locally, and how you want to do that. And finally, we're going to talk about what your application code can actually divulge about itself. So we're going to talk about decompiling apps and just generally what your code can divulge about itself. So right, a little bit about me. Thanks, Mark, for the introduction. But my name is Peter Organa, and I work at Civility Intersect. Ostensibly, my job title is Senior Engineer. But really what I do is I do Android code, back-end code, I do web, so JavaScript and such. And in my darker days, I've actually done a Windows Phone project, but let's not talk about that, okay? But I'm a bit of a generalist, so if you guys have any questions about the back-end side of things, I'll be happy to at least try to answer it for you. So right on. Why am I doing this? I have made a ton of mistakes getting into this job. Like, holy hell, have I fucked up. And what I want you to do is not make the same mistakes I have. The stuff I'm covering here is like super general. I'm not going to be going into bytecode, I'm not going into the nitty-gritty. I am kind of covering why we're protecting Android. So I don't want to talk about hows. I'm not going to be prescribing solutions to problems. I'm going to be suggesting a few. But I don't want to tell any of you guys, hey, do this, because solutions change year to year. But what I want to be talking about is I want everyone to have an empathy for the user. I want everyone to have an empathy for a client in their kind of situation. I want to say why we're protecting our users. And then we'll talk a little bit about how. But how doesn't matter. How changes year to year. Right. Oh gosh. Alright, well that's fine. Hold on. Everything's fine. So right. Yeah, I'm talking to developers here today, but I'm also talking to project managers. I want you guys to be able to answer or ask the right questions during the project lifecycle. Because backfilling security after the fact is fucked. You don't want to do it. It's going to cost a lot of money. What you want to do is have, if on the day before launch, your project manager comes up to you and says, yo, is the app secure? You're going to say, mm-hmm. But that's not the way you want to treat it, right? You want to think about this on a day-to-day basis, so you're not backfilling this stuff. And again, this is simple stuff. Like, I'm sure the projects you're all working on are way more complex, but just ask yourselves these questions as you're building the app. Designers, so when you're doing like an input field, like think about, do we need to hide this information? Do we really need to show an entire credit card number on a user's profile page? Maybe not. Like, but UX and design actually does have a huge impact on security. And what I want to kind of give you guys is my sense of paranoia, because I'm really anxious all the time, and I want you to kind of share my anxiety. Finally, assume everything I'm telling you is wrong. Again, I'm not prescribing solutions here, I'm just kind of giving you my paranoias. Alright, let's talk about OWASP. So OWASP is the Open Web Application Security Project. They're a non-profit group that kind of posts a list of security vulnerabilities every year. There's a link at the bottom there, don't worry about it, there's notes at the end of this presentation, and you guys just enjoy my ramblings. But OWASP they publish a top 10 list of things that you need to worry about on your app. Check it out, it's a great kind of list to go through, and you can kind of say, yeah, we're doing that, we're cool. They also have server-side security and all that. So anyway, my talk loosely based on these OWASP fellas, check it out. Next up. Securing your server. Okay, so ostensibly we're here to talk about Android, but I would be like super remiss if I didn't mention that the most important part of securing your app is actually securing your server. If your server is vulnerable, it doesn't matter. Like, a hacker isn't going to be, you know, tapping away on your Android device trying to hack your server. If they're going to be attacking your server, they're going to be doing it through curl, through Postman, through whatever. If you find vulnerability in your client's code, if you're working with a third party and you say, hey, this is no good, it's up to you to voice that. Nobody ever posts a review of an Android app saying, you know, the client was fantastic, but the server really fucked up. Like, it's you know, if you see something wrong with the server, if you know there's something wrong with the server, you've got to voice that stuff, because ultimately the server is where your actual vulnerabilities are. But that's not to say that the client doesn't matter. Let's get on to that. So first of all, communication. As I mentioned, communication. Easiest thing to secure, also most important. We're going to talk about HTTPS, what it is, and we're also going to talk about certificate pinning. But first, a story. Everyone here, we're starting a company together, and we're making an Android app. I'm going to be tech lead because I'm going to take all the responsibility, but you're all helping me. So check this out. We're going to make an app that lets us share Kung Fu moves online. Perfect idea, it was mine. So I'm gonna do the PHP backend. It's gonna be really cool. It's my first time doing it, but we'll save a bunch of money. Don't worry about it. So time passes. Application launches. My mom loves the application. Not a lot of users, but my mom loves it. Every day she goes to the web cafe, logs onto the free Wi-Fi, shares her Kung Fu moves. Awesome. Until I get a call at 2 a.m. Mom says somebody's hacked into her account and is posting Kung Fu moves under her name. Disaster. So, what happened? So it ends up, when she was logging on to free Wi-Fi, she was logging on to it's essentially a hacker's hotspot. And we'll talk, and this kind of leads us into man-in-the-middle attacks. So get this, when in the 90s and early 2000s, before Wi-Fi, man-in-the-middle attacks were these kind of abstract things, nobody really believed it. You had to essentially be the NSA in order to do a man-in-the-middle. You had to have a server kind of sitting in the line of communication. But as soon as Wi-Fi came around, holy shit, all you have to do is go into a place that's super trusted, say, you know, yeah, this is a legit Wi-Fi hotspot, and anyone can connect to it. So, like, I mean, I bet all of you have connected to Mars Open Wi-Fi, but, like, I don't know if a lot of you actually thought to trust it. And that's the thing, is, you know, your actual user doesn't know whether or not the Wi-Fi hotspot can be trusted. Yeah, hold on. Yeah, all right. Sorry, guys. All right, so, easy solution, HTTPS. Everyone uses it, no problem. It's built into Android, it's built into Android, there's nothing to worry about, everything's cool. But, well actually, let me take a step back. If you're building your own backend, make sure you enable HTTPS, make sure your communications layer is secure. Don't try to hack in your own encryption scheme. It's not going to, you know, like HTTP is trusted for a reason, and we'll talk about that in just a second. Users assume your application is secure. So if you think about using Chrome or Firefox or whatever, your browser, whatever browser you use, in the top left corner you'll see that little lock icon. And that little lock icon tells you as a user that the website you're using is secure. The problem is on your Android app, that isn't there. That lock icon is not there. Your users just assume you're doing the right thing. And here's where this kind of idea of you being your user's advocate or your user's hero really comes into play. Your user assumes you're doing the right thing, and you have to do the right thing, which is to make sure that communications layer is secure. So if you're not using HTTPS, your user will never know about it. So, a little bit about HTTPS. Now, many of you guys might think this is super basic, my apologies, but I think it's a really cool kind of system. But before we talk about HTTPS, let's talk about asynchronous or asymmetric and symmetric encryptions. And if you don't mind, thank you. So check this out. Symmetric encryption. Analogy time. Mario and Peach each have a key. The key is exactly the same. It is a copy. They can each open this box, and they can put messages inside the box and send the box to each other. And this is the analogy for symmetric encryption, that anyone who has the key can encrypt a message, and anyone can unencrypt that message as long as they have the same key. Cool? So Mario takes the box, opens it up, puts a message inside of it, closes the box and locks it. The message is now encrypted. He sends that box over to Keek. She opens up the box, takes the message out, unencrypted. Cool. Now we're going to talk about asymmetric encryption, which is, you probably know this as public-private key. And here the idea is that Mario is super loose with one of his keys. There's two kinds of keys. There's a private key and there's a public key. So Mario has the only key that can actually open the box. He's the only one who can open the box and read the messages inside of it. But he's super loose with his public key. He gives it to everybody, like absolutely everybody, because that key, that green key, that public key, can only close a box. It can only lock it. So he gives his key to everyone. They can lock this box, put their messages inside it, send it to Mario. Mario can open the box and read the message. That's his private key. And the cool thing about this is that anybody with this public key knows that only Mario can open this box. They know that nobody's going to intercept this message and read it, right? This is a really dope system because it gives you this ability to have trust that your message, when it's sent out, is actually going to be read by the person it was intended for. So this leads us to actually, what is HTTPS anyway? So first, let's introduce our actors. First, we have our phone, or your mobile device, and next we have our server. So, the phone talks to the server and says, "Yo server, let's talk." Oh, I forgot to mention, this is way oversimplified. Holy shit, are there more steps? But I just wanted to give you kind of the gestalt. I wanted to give you the low-level understanding here. So please don't go repeating this as this is the actual honest-to-God truth of what's going on. There's not actually like a phone, like an old-time pixely phone talking to things. So, the phone asks the server, says, "Hey, I want to start talking." The server comes back and passes it a certificate. We're going to talk more about the certificate in just a bit. But the certificate proves that the server is who it says it is. And this is really important because anyone can ultimately pretend to be Google, Google.com. The certificate proves that the server is who it claims it is. Next, it passes one of those public keys. It passes a key that the phone can use to encrypt a message that it will know only the server can understand. Next up, and here's it again. This is where the certificate of authority, excuse me, I'm Polish, and the one word I can't pronounce in my life is authority, but there it is. Perhaps I'm an anti-authoritarian. Anyway. So I'll just refer to it as a CA. So the phone talks to the CA, and I'll talk a little bit more about this later because it's actually super important and a little bit complicated. But the phone talks to the CA and says, "Is this certificate trustworthy?" And the CA says, "Sure, of course it's trustworthy." And now the phone creates a symmetric key. Remember, the key that only two people can have. Encrypts it using the public key and sends it over to the server. So now we know that the server has a key that is safe for communication. And it's this really clever system, and it's really cool to know that we're using these two kinds of encryption, and we're I just think it's neat, you guys, and I just wanted to share that with you. But as I mentioned about that CA, so again, the CA. So what a certificate of authority is a thing that validates certificates, but really what you're looking at is on your phone, on your operating system. So Firefox has its own set of certificates, and operating systems have their own set, but we won't go into that. It's a way of verifying these certificates that are passed from the server. And what it ends up is that this isn't necessarily a trustworthy thing. So back in 2011, there was a hack in Iran and in France, and a bunch of these certificates got loose. It's cool, these certificates expire, but what ended up happening is that, the idea that these certificates are now 100% trustworthy isn't 100% there. So a lot of times now, Android apps are actually doing what's called certificate pinning, or making sure that the certificate can be trusted, or a certificate can be trusted, or essentially circumventing I'm not going to say circumventing, but let's go into that in just a sec. So what you can do is something called certificate pinning. Oh gosh, I think I'm going too fast. Anyway, it's cool. You can do something called certificate pinning. And what certificate pinning does is it tells your application it's only going to trust one singular certificate. So normally, when your phone reads a certificate, it has a base of 100-something certificates on the device. And it checks it against those certificates. But if one of those have gone rogue, you might never know about it, and somebody might actually be spoofing that certificate. And this actually happens, like, it's rare, but like it is a legitimate attack. So what you can do, though, and this is, sorry, what you can do is that you can use a library like OKHTTP to do what's called certificate pinning. And what certificate pinning does is it says, I'm trusting one certificate. I'm not trusting this entire pool of certificates, one of which may have been hacked. I'm only going to trust a single one. So you kind of have to have a buy-in here from your server guys. You have to say, server guys, I need you guys to promise not to change the certificate on me. And because as soon as that certificate changes, you're going to have a problem. And that problem is that your app's not going to work. So what you do here is, because, as I mentioned earlier, certificates do expire over time. And when they do expire, your application is essentially going to go dead. So you have to have something called, you need some sort of mechanism in the background to make sure your app is updated as soon as the certificate is updated. So what you do is essentially you can create a scheme where you're talking to a third server, something that's on a different network, because otherwise, your HTTP stream is going to go down. Or you just tell your app that if it ever sees an untrusted certificate, you just pop up an app and say, hey app, you need to update. Because people don't always have forced update turned on. So even though you push a new certificate, you can't guarantee that your entire user base is going to have it. So you need some sort of mechanism to update your application if the certificate goes rogue. Okay, I just wanted to put a really quick example of just how simple this is to do. All you're essentially doing is, this is OKHTTP, super common library. You say, I'm going to do certificate pinning. This is the public hash of my certificate. It's like ridiculously easy to do, but remember, the troublesome part is making sure your server guys are on board. Okay, network, done. So let's talk about storage a little bit. Let's talk about Android storage and where can we actually keep stuff. Yeah, so cool. So back to story time. So despite our earlier security mess-ups, the application's actually doing well, and we've actually, added people to our team, including salespeople and UX people. So our sales and UX people say, hey, you know what? Maybe we should start selling Kung Fu moves online. And I think that's a great idea. So let's do it. We're going to create a SQL database on our Android app to store our users' financial data. No problem. SQL is super safe. And let's go to market. That's an open Pokeball, by the way. But so guess what? Mom calls 3 a.m. Her credit card number got nabbed. I'm like, Mom, what happened? Well, it ends up she sold her phone. And that's really all it takes. So it ends up that actually Android storage isn't all that safe at all. Like, this is a legitimate, this is a shared preference file right off of an Android device. I got it off of the device using ADB backup. Super easy to do. It's kind of ridiculous how simple it is to just pull storage off of an Android device. That's a working email address, by the way. I'm really proud of it. But what I'm getting at is that actually Android storage, not all that secure. And yeah, again, we need to advocate for the users here. Like, some people say, hey, it's not a problem if the user loses access to their phone or if they get their phone stolen. But no, like, people sell their phones, people get their phones stolen. It's like a normal thing. We can't user blame and say that it's our fault. It's not our fault. Why wouldn't you clear up your phone? Well, maybe my mom doesn't know how to clear her phone. It is a normal thing. I think we need to have like proper empathy for our users. We need to actually consider how we're storing our data. So let's talk about levels of storage. Storing stuff in SQL, not safe. Shared preferences, as you saw, not safe. At the very least, you can allow backup false in your Android manifest. It makes it a little bit harder, but rooted devices will have no problem grabbing that data. Absolutely use shared preferences, but maybe use it for actual preferences, like, yeah, please send me emails, whatever. But it's not a safe place to put things. Next up, we've got encrypted storage. So this is where a lot of people kind of do custom encryption schemes. So you might have local symmetric encryption. You'll hold a key in your Android code and use that key to encrypt and decrypt data. Fine, but people can decompile your apps, grab that key, and read it. So then people say, fine, let's use Android Key Store, because Android Key Store is a place that's ostensibly made to store Android keys, to keep Android keys safe or store encryption data. And in fact, we store a lot of data at Symbology Intersect in our Android store, but we do stuff that we know that if it ever gets out of our hands, we won't be upset about it. So this is a. Well, let me just turn my notes here. Yeah. Okay. So let me just go on about Android Key Store just for a minute, in case anybody's not familiar. It is a place to store encryption keys. There are libraries that help you use it and to pull information in and out of it. But again, not 100% trusted. So if you go online, you'll find vulnerabilities for Android Key Store, and we can't guarantee that Android Key Store will be safe in the future. So finally, we've got level 3, which is, don't store any information on your phone at all. Just keep it all in the cloud, keep it all on your server. And it's going to be a contentious issue. Some of you guys are going to be pissed with me for even suggesting it, but if the data really needs to be secured, don't store it on your phone at all. Just keep it on the cloud. We're going to talk a little bit about storing passwords locally. Mostly I'm going to say don't do it. The problem is a lot of people use their login and password in more than one place. So if you're making an app for a client and they say, hey, we need you to store your email address and password for the user for quick login, that's no good, guys. That login and password might be used again on Facebook or on their app or on their Gmail account. Like storing, it's like one of the most irresponsible things we can do is to actually store a username and password on an app. What you can do instead are use what are called session tokens. And I bet everybody here knows what a session token is, but just in case, when you send a login and password to a server, the server can push those two things together, create a random key that will represent your login, and it'll send that key back to the client. The client can then send that random key to the server again and again and use it to re-authenticate the user. Just make sure that this thing expires. If your session token never has an expiry date, then it might as well just be a login into your server. Cool. Hey man, how much time do we got? That's okay. All right. So let's talk about reverse engineering and data leakage. So back to stories. Our Android app, despite its earlier security problems, is doing great. We've got a ton of users. Everybody's using it. Everybody's sharing their goddamn kung fu moves. It's wonderful. But there are clone apps on the store, which is cool. Everyone's still downloading ours. And we used a weird spelling of kung fu, so sometimes people have a tough time finding our app. But that's alright as well. Everything's fine. Except, Mom, when she got that new phone, she had trouble finding our app, and she ended up downloading a clone app, which ended up sending text messages to Indonesia, and now she has a $5 million phone bill. So it's a little bit of a far-fetched story, but it is true that people do decompile Android apps. And I'm using an example here of Desert Golf. I don't think any of these ever clone apps are hacks or anything, but it's just to show that finding similar applications online is pretty easy to do. But in short, decompiling an app is ridiculously easy to do. I'd recommend all of you pick up something called Dex2Jar, which is an app. It's an app that lets you decompile APKs, look at the source code. It's fun to do just before you ship, because you get to see how easy it is to read actual application code of your app. So, easy solution, and again, I don't want to prescribe solutions, but ProGuard is what we use at Symbology. There are applications called ProGuard and DexGuard, and what they do is they obfuscate your code, make it harder to read logs, and it shrinks and optimizes your code as well. So I'll show you in just a sec what obfuscated versus non-obfuscated code actually looks like. But before we do that, let's talk about the headaches. If you are going to be doing code obfuscation, do it at the beginning of your project. The worst thing is finding out that your code doesn't compile because you've applied ProGuard to your code. It is nightmarish, you guys. Like seriously, try to have a production build up that actually uses ProGuard, obfuscates your code. It'll save you a lot of time in the future. Also, stack traces get really difficult, so you have to create mappings of your application. I'll show you why in just a sec. So, hopefully you can see, yeah, it's barely readable, but what you can see up top is an APK that was not obfuscated at all. Just open that up in Dex jar, and below is an obfuscated piece of code. So what I'm trying to show you here is that obfuscated code is totally readable, but it becomes much harder. So, if somebody is really dedicated, they can probably find a secret key inside of your code, but makes it way harder to do. And up top, again, it's almost like the exact code of your app. So, what else can we do besides just pro-guarding the app? One of the recommendations, not my recommendation, but one of the things you can do is actually start writing C++ NDK or native development kit libraries. This becomes, you need to have a really dedicated individual who's going to decompile your app and pull out the NDK and read it. Again, this is just levels of obfuscation. It'll never be 100% safe, but you just make it so difficult that the next guy over is going to want to find an easier target. One thing to say about obfuscating NDKs or C++ libraries is that if that library is tiny and only contains like one secret key, it'll be pretty easy for the guy who's hacking it to figure out what's in it. Android safety net. So this is something that I don't actually have a lot of experience with, but in my research I just see it again and again. And there's this thing called the Android Safety Net API. And it's an API that lets you actually check a bunch of things. It checks if your device is rooted, which is real important. Like if you are worried about... Actually, let me talk about this for just a sec. The first people who actually used Safety Net, or one of the first people, were the Pokemon Go people. Because people were like spoofing Pokemons on their phones. And they were doing it with rooted devices. And that's a perfect example of when you're actually super concerned about the bytecode. When you're doing a lot of processing on the client, you're not offloading it onto the server. So Android Safety Net checks if your device is rooted. It has a safe browsing check. It has capture support, and finally you can see if other apps that are on your phone are unsafe. Okay, remember the hodgepodge of paranoia? This is time for rapid fire. So, untrusted third-party libraries. All of us use third-party libraries, totally accepted, absolutely go for it, but just make sure that your libraries can be trusted. So that's check for stars, check for forks, make sure your application, the library is updated frequently. Like you're kind of, it's the wisdom of the crowd kind of thing. Like see if other people are using it, make sure it's updated frequently, make sure the recent update is new, because a lot of times projects go cold and then important security updates might have been missed entirely. And finally, check the license. We've run into this a couple times where we use a library, we're super happy with it, and then we find out that it's not publicly available. So just go on TLDR Legal and make sure the to for your third-party app is legit. Or it allows you to do this type of stuff. Next up, intents and deep links. Gosh, do I want to explain what an intent is? How about this? Don't use explicit intents, and if you do, just make sure your application is ready for it. Essentially what you can do is have another application pick up a message that your app is sending. And a deep link is something like a URL that your app will open. So sometimes you'll click on a link or a push notification opens up your app. These can be exploited, and the easiest way is if you say you put a URL inside of your deep link. That might actually force your app to open up another website, and that's no good for the user because they trust that your push notification is legit. So just make sure your deep link is handled by the app correctly. SQL injection attacks. Same as you guys probably doing this, or okay. If you're using a SQL database, there's a potential for a user input to be used against the SQL database. I mean, it's best practices. I'm sure if you're using SQL, you're already doing this. But just use what are called prepared statements, or there's ways of making sure that Android scrubs the user inputs before they actually read the SQL database. Keyboards. If you are... Okay, weird edge case here, but people download custom keyboards. And when they do, those custom keyboards might actually be sending off user inputs out of the server. So that means that the user's custom keyboard might actually be logging the user's inputs and sending them to home. There's a couple things you can do about this. I haven't actually tried this stuff myself, so I'm a little wary about it, but you can check for the kind of bytecode the keyboard accepts, and You can check for what kind of bytecode the keyboard accepts and block it. Also, watch out for autocomplete. So users might type in something sensitive into a field, and that will go into the user's dictionary, and somebody might be able to grab the user's autocomplete dictionary and read that data back. These are kind of like high-level things that most of your apps don't need to worry about, but I'm just mentioning them because they are like legit possibilities. And finally, clipboard. So the user might have copied and pasted their credit card number, for example, and when they exit the activity, they might have somebody might be able to paste that out. So easy thing to do is just clear the clipboard or populate the clipboard with an empty string when you go on pause. Screen capture. So here, I'm showing this, like a backgrounded Android application here because this is actually a legit thing. When you background an Android app, it doesn't actually background the app itself. It takes an image of your Android application and sends it off to the background, but it actually saves that screenshot. And what that means is if the user backgrounded the app on a really sensitive screen, somebody might actually legitimately be able to read back that screenshot and use it against you. So easy thing to do here is you set layout params flag secure on your activity that needs to be secure, and all of a sudden that screenshot will just end up being a gray blob. Additionally, you can use that to stop screen readers. So you might have you might have an app running in the background that's actually capturing video of your user's application, and that can be used again for nefarious means. So, Peter, are you saying we're screwed? There's a lot of things here, and it gets kind of scary, but that's not really what I'm trying to tell you guys at all. What I'm trying to say is you guys are heroes. Security isn't that tough, really. You make sure your network layer is secure, you do everything you can, like you make sure that certificate pinning is implemented, you make sure when you launch your app that HTTPS is actually activated, because hell, a lot of people apparently disable HTTPS for debugging purposes and then forget to turn it back on. It's apparently one of the #1 vulnerabilities. You make sure that if you're going to store data, you make sure you do it for the right reasons. So if you're going to be storing login and password, well, you don't do it. You do a session token. But you don't store the session token in shared press. Encrypt it locally, So if somebody's going to get at that session token, at least they're going to have a tough time of it. And finally, if you're going to store really sensitive data, like stuff you'd never want to escape, just store it on the server and forget about the client entirely. And it might be not the ultimate user experience, and you got to talk to your UX people, you got to talk to your designers, but you got to make sure that you do the right thing. And finally, you make sure your bytecode is safe. Now, it's never, as we showed, it's never going to be 100% safe, but it's going to be, you just make it hard enough that the hacker has to jump through some hoops and maybe they'll attack somebody else. Shitty thing to say, but, it's the right thing to do. And finally, there's a hodgepodge of security. So again, I'm not going to go over that stuff again, but what I'd recommend is just hit up the OWASP top 10, go over your checklist, make sure your app is secure, think about your users, don't leave security for the end of the project. And I think I'm out. Thank you guys.